Hey guys, so this is the Honors Math 3 quiz review. If you are up for a challenge, I would still try it. It is similar to the academic one, but there are some challenges. So we are going to use this graph and find the value of f of 2. 2 is right here because this is saying x equals 2. Remember, when the number is inside, that's x's spot. So I'm going to go where x is 2 and look for my graph. The value, or the y, or the f of x value is 5. Number 2, f of x equals negative 2. So now in our brains, we're thinking the y value at negative 2. So I'm going to go on the y, negative 2, and I'm going to look for my function, which is right here, would give me an x equals negative 4. What is the domain of this function? So domain are your x values, and you always want to go from left to right. So I'm going to go the left side, so that's negative infinity, to the right side. So this has an arrow over here, so that means it's going on forever. So the domain would be negative infinity. As I move to the right, I see a hard stop point right here. So that domain actually ends at 2, and it includes 2 since that's a solid point. What is the range? So the range is the y values, and you want to go from the bottom to the top. So the bottom of the graph is our negative infinity. The top of the graph is positive infinity. So as I move from the bottom, I see a negative arrow, negative infinity, all the way up to the top. There's a hard stop right here, and that y value is 5. Write the function rule. So this is a piecewise function because I can see pieces of a different function. This piecewise function has 3 lines. So this first line is linear. So my m, if I count, is up 1 over 1, rise 1, run 1 would make my slope 1. I can't see my y-intercept, so you could extend it to see that your y-intercept is 5. So if you did that, you would get your function would be y equals 1x plus 2, or just x plus 2. But I really want you guys to get in the habit of, when that y-intercept isn't shown on the graph, to use point slope. And if we're doing piecewise, we're going to use a modified point slope, because remember, in piecewise, the y equals that's over here, or the f of x equals, is for all of the pieces. So here I'm just going to use this point because it's nice and big. So that point is negative 1, 1. So when I plug it in, y equals, my slope is 1, x opposite of negative 1, so positive 1, or you can think negative, negative 1, and then add my y value. So I'm going to plug that in here, and that's x plus 1 plus 1. If you want that 1 in front, that's fine. And now I need to say the domain of that piece. So this piece goes from negative infinity all the way up to negative 1, and then it stops. You could write that as x is less than or equal to negative 1. Either of those are fine for my domain. All right, let's look at the next piece here. So the next piece here is a horizontal line. So that's a constant function, and we're thinking, hoy, horizontal line, 0 slope, y equals. So y would have to equal 1 here because that's where it hits my y-axis. So this is just the equation, y equals 1. So the y equals, or f of x, is right there. It's 1. And this section goes from negative 1 to 1. So negative 1 could be in either piece because it actually overlaps there. But since I used it here, I'm not going to use it here. So I'm just going to go from negative 1, don't include that, to positive 1. It would be okay if this was a parentheses and this is a bracket, but you cannot have 2 brackets, because if you do, then your domain, or your x values, is repeating, and x cannot repeat. All right, so here we go. Or you could have this as negative 1 is less than x less than or equal to positive 1. So you might see it both ways, and I will allow both ways. Same thing here. So if you missed it, if you had this equation as x plus 2, you would get credit because that is still the equation of that line. There's actually unlimited equations that would work for that line. All right, the next piece is another linear. So When I go here, you know what, yellow is probably not the best. When I go here, this is linear, so you can think y equals mx plus b, but again, I don't see my b, so I'm going to use modified point slope here. My slope, I'm going to count 1, 2, 3, 4 over 1, so this is rising 4, running 1, so m is 4. My point, I'm going to use this first point that I see, which is 1, 1, so y equals 4. X minus 1 plus 1 is going to be the equation for that one. 4x minus 1 plus 1. And I could have a different version of that. The way I check is I just distribute and combine like terms. All right, so this one goes from 1. And again, I use the 1 there, so I can't use it again here. You could not use it here and use it here, but just don't use it in both. So this goes from 1 to 2, and it's a hard stop at 2. Or you could write that as 1 less than x less than or equal to 2. But I should include 2 since that's a solid point. Let's look at 6 through 10. So first thing I want to do is I want to graph. When you graph piecewise, I highly recommend that you use a pencil. So this is quadratic. So when you have a squared, you should know that it's going to form a parabola. So this is actually a negative quadratic, because my a is negative here. So if I look, my vertex is my HK. This one you might want to think of as being y equals negative 2, x minus 1 squared plus 0. So the vertex here would be 1, 0. So I'm going to go over 1, up 0, put a point, and then it's going to open down. So remember, as I move, I'm going to go right 1, is a times 1 squared. I have to square because this is a quadratic. So a is negative 2, 1 squared is 1. Right 1, down 2, because that's negative 2. Now I'm going to go right 2, a times 2 squared. Negative 1, that's my a value, times 2 squared is 4, gives me negative 8. So right 2, down 1, 2, 3, 4, 5, 6, 7, 8. Remember, your quadratics have your axis of symmetry, so this point is going to match up, and then this point is going to be 2 to the left. So here would be my normal quadratic, if I just had a quadratic. But this one says, I want this value from 0, and include 0, so at 0, I'm going to put a solid line, all the way up into 3. So here's x is 1, x is 2, x is 3, and at 3, you actually need an open circle. So I'm going to erase everything that doesn't fit. At 3, I'm going to put an open circle there because it is not or equal to there. So there's that. All right, the second function here is a linear. This is point slope form. So as I go to the second one, this is modified point slope form, excuse me. I can see that my slope is negative 2 and my point is opposite of negative 3 and then 2. So I'm going to start 1, 2, 3, up 2. Here's my point and my slope is negative 2. So down 2 over 1, down 2 over 1, down 2 over 1. So here's the line that I'm working with. This time I want to go from 3, 1, 2, 3, and include that point, so make sure you don't go past it, all the way up to 5. So 4, 5, and then don't include the point at 5. So there's the piece of that linear that I want. The last one is a constant, y equals negative 2. Remember, y equals a number is a horizontal line with 0 slope. So I'm going to go y equals negative 2, and it would be this horizontal line here. But my domain of this piece is just from 5 to 8. So this happened in our packet. I want to include the point that actually wasn't included in that one since they overlap. And I want to go all the way 6, 7, 8. 8 is open because there's nowhere equal to. 5, 6, 7, 8. Okay, so there's my function. When I find the domain, I now have two options. I have the graph, or I have the set of domains here. So probably the easiest way is to use the set over here. So I know my smallest is 0, and it includes that, and then it goes to 8. You can see that by reading the x-axis. So it includes this from left and all the way to the right. It stops at 8. 8 is a boundary. It doesn't include it, so we put a parentheses. What's the range? So the range, you can either use the function and plug in the smallest and then plug in the largest, or you can read from the bottom of the graph to the top of the graph. So the bottom of my graph is -1, 2, 3, 4, 5, 6, 7, 8. So -8 does not include that because that's an open circle, all the way to the top, which would be +2. What's the value of g of 1? So you can use the function, the graph, and find that that hits at the y-axis, the x-axis, so that's an x-intercept, so that's 0. Or you can say x is 1 is right here, it's between 0 and 3, so -2 x minus 1 squared, -2, 1 minus 1 squared, -2, 0 squared would be -2 times 0, so still 0. What's the value of g of 6? So 1, 2, 3, 4, 5, 6. Find my graph would be -2. That's saying x is 6. Or you can plug 6 in here, and it says whatever values are in between, including 5, up to 8, it's constantly -2. All right, let's look at page 2. I'm sorry this video is so long. Write the absolute value. So the absolute value function, remember, is, and I can get a pen as long as I don't mess up, because some of you have said pencil can be hard to see. All right, so there's my standard form of an absolute value. So A is the slope. So this slope is definitely going down 1 over, well, let's not use that one. Let's find this one. 1, 2, 3. So let's go down 3 over 1, 2, 3, 4, 5 over 5. So my A value here is going to be -3/5. HK is my vertex, which is right here. So that's -2, +3. So HK is -2, +3. So I'm going to write opposite of -2 plus 3. As a piecewise function, there are two pieces. So this first piece would be my left side and would have a positive slope. So 3/5. And then the point would just be, so I'm using modified point slope again. Oh, losing my mind, guys. I'm so sorry. All right, modified point slope. So M, we already know, is +3/5. It's just the opposite of, since absolute value, you go the opposite direction from 0. Right here, 0. We have some opposite to the right and some to the left. All right. My point here, I'm still going to use that same point, -2, 3, because that point works on both. So +3/5, x plus 2 plus 3, and that domain would happen from -infinity up into -2. So -infinity to -2. And then the other piece has the same line, but just the opposite direction. So opposite slope, same point. And that one's going to go from -2 to +infinity. You can include the -2 in either pieces as long as it's not in both. You can have different forms for these lines as long as it still matches up to those lines. All right, find f of -2. So f of -2 is +3. F of 3, 3 is 0. Find x if f of x is 3. So now I'm going to go to 3 on my y, and that's still my vertex, so x is -2. Find x if f of x equals 0. So it's 0. Now I hit it twice. That is -1, 2, 3, 4, 5, 6, 7. So x is -7, and x is 1, 2, 3. So y is 0, hits those 2 points. So there's 2 solutions. Given the slope and the point, write the equation in point slope form and modified point slope form. So point slope form is this, and then modified just means that we take that y1 value and we move it over. So I have my point and my slope. So this is x1, y1. So point slope would be y minus 5 equals m. x minus -4 or +4. Now when I modify point slope, I'm just going to move that 5 over. So it's going to be -2/3 x plus 4, and this time plus 5. Given 2 points, write the equation of the line in modified point slope. So the first thing I need to do is find my m. We should be great at this by now. So x1, y1, x2, y2, -4 minus 6 over 5 minus a -9, or opposite -9. So we would get -10 over 14. That does reduce to -5/7. So I can use either point into this modified point slope. I'm just going to use the first one. You could use the second one, but this would be y equals -5/7. That's my m. X opposite of x1, and then plus y1. Use the function g of x and f of x to answer the question. So g of 2 means I'm looking here because that's 2. I'm asking me x equals 2. Not that one, so I'm going to go to this one. That would be 3. F of -1, f means I'm going to go to this function, that's f. -1 would be less than 3, so I'm going to plug it into this, -x minus 4. So -1 minus 4 would be 1 minus 4, so -3. F of 4, still in this function. 4 is in between here, so x squared minus 7. 4 squared minus 7. 16 minus 7, 9. Find 4 times g of 3 minus 3 times f of 10. So 4 times, let's see, g of 3, I'm going to go to the g. 3 is 1, 2, 3 right here. That's 3 on the y, so that's going to be 4 times 3 minus 3, f of 10. 10 is less than or equal to 10, so I'm thinking x squared minus 7, or 10 squared minus 7, or 100 minus 7, so 93. 93. So we'd have 4 times 3 minus 93. Minus 3 times 93 should give me -267. Okay, hope that helps. Have a great day.